Suppose we are given this question, y squared positive x squared times dy over dx is equal to xy times dy over dx. So foremost, what we can do is we can club these two quantities and take dy over dx as a common factor out. So let's do that. So this is going to be x squared dy over dx negative xy dy over dx, and which is equal to negative y squared. So I'm moving the y squared to the other side. So this is going to be dy over dx of x squared negative x times y is equal to negative y squared. So moving this down would give us dy over dx is equal to negative y squared divided by x squared negative xy. I don't want to have a negative sign in the numerator for y. So I'm going to rewrite this as negative of y squared. Take a negative sign out. So this would become xy negative x squared. So these two negative signs can be cancelled, giving me dy over dx to be as y squared divided by xy negative x squared. Clearly this is a homogeneous differential equation. The degree of y is 2, the degree of the denominator is also 2. So let us make this substitution that y being equal to vx, and we differentiate this, we get dy over dx is equal to v times differential of x is 1, positive x times differential of v is dv over dx. I would use this into this system. So this is going to be dy in place of dy over dx. I don't need to write this again. I'm going to substitute v positive x times dv over dx is equal to, in place of y, it's going to be vx raised to the power 2 divided by x times vx negative x squared. This is rewritten as v positive x times dv over dx is equal to v squared x squared divided by v times x squared negative x squared. Now this is equal to v squared x squared divided by, I can take an x squared common, so that's going to be v negative 1. So clearly the x squareds that you see can be cancelled, giving me v squared over v negative 1. On the left I've got v positive x times dv over dx. So what I'm going to do, I'm going to move this v to the right side. So that would give me x times dv over dx is equal to v squared divided by v negative 1 negative v. Now taking the LCM as v negative 1, this is going to be v squared negative of v times v negative 1. So this is equal to v squared negative v squared positive v divided by v negative 1. Now clearly the v squareds that you see can be cancelled, giving me v over v negative 1. On the left I've got x times dv over dx. Using variable separable, I can rewrite it now, v negative 1 times dv divided by v is equal to dx over x. Now this can be rewritten again as v times dv with the v in the denominator followed by dv over v is equal to dx over x. Now integrating both sides, we get so integral of this, integral of this, integral of this, the v gets cancelled. So this is going to give me v, this is going to give me ln v, and this is going to give me ln of x. I need to add a constant, so I place ln c. Now I move this negative ln v to the other side, so that would give me v is equal to ln x positive ln c positive ln v. Now I know a formula, ln a plus ln b is equal to ln ab. Using this formula, I can rewrite this as ln x, v and c. It doesn't matter in what order you're writing, but just write it in this fashion. This is equal to v. Now we know that y is equal to vx, so this implies v is equal to y over x. So substitute it. So this is going to be y over x is equal to ln of x times y over x times c. this x that you see here can be cancelled, giving me ln of y times c is equal to y over x. Now this is to the base e. I can rewrite this as e raised to the power y over x, okay, is equal to y times c. If I move the c down, this is going to be y is equal to 1 over c times e raised to the power y over x. I can rewrite this as some k times e raised to the power y over x, which is equal to y, where you can say k is equal to 1 over c. You don't need to say that, you can simply say k is a constant.